Introduction to sequences. A sequence is an ordered list of numbers. If I had 2, 4, 6, 8, and so on, I have an infinite sequence. Also, if I had 6, 13, -20, 0, and so on, I also have an infinite sequence. The difference between the two is that if I look at the first sequence, I can easily see that each time I've added 2 to each term. In the second sequence, I can't tell what I added or what would come next in the sequence. Let's look at this finite sequence in the table. I have 5 terms. Here are my terms. And here are my term numbers. Normally, sequences are written in subscript notation. For my first term, it would be a sub 1, and its value or the term is 1. A sub 2 is equal to 3. A sub 3 is equal to 5. A sub 4 is equal to 7. And A sub 5 is equal to 9. Now, we're going to talk about an arithmetic sequence. I know some of you probably thought you pronounced that wrong. In elementary school, when you talked about arithmetic, it was a noun. In this case, an arithmetic sequence, this is an adjective, so it is an arithmetic sequence. Let's look again at this finite sequence. If I look at my terms, from 1 to 3, I have 2. From 2 to 5, I've added 2. From 5 to 7, I've added 2. And from 7 to 9, I've added 2. Well, I have a constant rate of change. And I know that you've heard that before, constant rate of change. That's what a slope is. As far as our sequences, though, it's called a common difference. And it's denoted by the little letter D. We do have a common difference. D is equal to positive 2. Now I would like to graph this sequence. We can set them up as points. I would have 1, 1, 2, 3, 3, 5, 4, 7, 5, 9. Let's graph them. Since we have a constant rate of change, I'm going to go over to 1 and up to 1. But since we have a constant rate of change, I'm going to use slope as rise 1, 2 over 1. Is that 0.23? Yes. Rise 2 over 1. Is that 0.35? Rise 2 over 1. Rise 2 over 1. And I have 5, 9. It does have a linear relationship. So this is an arithmetic sequence. It has a common difference. Let's look at explicit formula. The explicit formula of an arithmetic sequence can be used to calculate any term in the sequence as long as we have a sub 1, as long as we have that. Well, the theorem to find the nth term of an arithmetic sequence, there is a formula for it. We're going to look at the formula. A sub n, to be able to find any term in a sequence, is equal to a sub 1. And in this case, I have a sub 1 is 1. Plus my difference, which is a positive 2. 2 times n minus 1. A sub n is equal to 1 plus, and I'm going to distribute 2n minus 2. Then I'm going to combine like terms, so I have 2n minus 1. And this is the explicit form for the finite sequence above. If it was an infinite sequence, I could check any number. If I wanted to know what the 100th term was, I would just substitute 100 in for it to be 2 times 100 is 200 minus 1 would be 199. And this is the basics of arithmetic sequences. Now we have an example. Is the sequence arithmetic? Well, we know that by definition. We're just going to see if it has a common difference. We have plus 3, plus 3, plus 3, plus 3. And it is an infinite sequence. We do know that we need a sub 1. A sub 1 is 1. It's our first term. And we need our difference. Well, our difference is equal to 3. We can set our formula up. A sub n is equal to a sub 1 plus d times n minus 1. A sub n is equal to, we just substitute in, 1 plus d, which is 3, times n minus 1. A sub n is equal to 1 plus, I'm going to distribute, 3 times n is 3n, 3 times a negative 1 is a negative 3. Combine like terms, that gives 3n minus 2. The explicit formula for this arithmetic sequence is a sub n is equal to 3n minus 2. You can definitely see it looks linear. Looks like slope-intercept form. We've answered this question. Yes, it is an arithmetic sequence. We figured out the explicit form, and now we want to know what is the 10th term. I'm going to use my explicit formula to find my 10th term. A sub n is equal to 3n minus 2. My 10th term, a sub 10, is equal to 3 times 10. I'm substituting in for n, minus 2. A sub 10 is equal to 30 minus 2. A sub 10 is equal to 28. So our 10th term is 28.